Welcome back. You're almost done with your notes for 3.2 linear functions. We're just going to continue here. A solution of a linear equation is an ordered pair, x comma y, that makes the equation true. So it's called a solution if we can plug in that ordered pair or substitute that ordered pair into the equation, and when we simplify we get a true statement at the end. We can find a solution by starting with just an x, just an input, or we can start with just a y or an output, and we can solve for the other piece of that solution. There are two types of domains when we're talking about linear functions. There are discrete domains and continuous domains. So go ahead and draw a line down the middle of your paper. We're going to talk about these side by side. We're going to start with the definitions. So, discrete domain. Remember, domain is talking about input values. So domain is a set of input values. That definition is the same from 3.1. For it to be discrete, it contains only certain numbers in an interval. So only specific numbers are included in this. And you can think about it. Think about if you were told a friend, oh, I really need you to be discreet about this. Discrete meaning I only want you to share certain pieces of information. Discrete. So only certain numbers are included, not every number. On the other hand, we have continuous. Continuous means never ceasing, all connected, something that continues on. So this is a set of input values that consists of all the numbers in an interval. Okay, so be discrete, only share pieces, bits, not the whole thing. Continuous means keep it going. In a line, we want to include everything. Let's show some examples of this. An example of discrete data, for example, y equals 1.25 times x. This is the cost y of buying x bottles of apple juice. And there's a max of 3 bottles that you can buy at Walmart. Perhaps Walmart is running low on apple juice and they don't want you to buy them out. So you can only buy 3 bottles at most, and you're buying bottles of apple juice. Now this would be discrete because there are only 4 options for you. It's impossible to buy half a bottle of apple juice at the store. Okay? They're not going to do it. You drink half the apple juice, you say, sorry, I'd like to give you back the rest. The cashier is not going to have it. So discrete, because you can only buy whole numbers of apple juice, specific values of apple juice, this is called discrete data. In this scenario, you can only buy 0 bottles of apple juice, 1 bottle, 2 bottles, or 3 bottles because of this max. That makes our domain just 0, 1, 2, and 3. This would be a discrete domain because we cannot buy parts of a bottle of apple juice. We have to buy whole bottles at a time. So only certain inputs make sense in this situation. On the other hand, if we have a continuous domain, y equals 130x, notice these equations look very, very similar. So the only way you can tell if it's discrete or continuous is by the context. This equation happens to be talking about calories, y, and x number of cereal bars that you've eaten. Now in this instance, it is possible to eat half a candy bar, or a quarter of a candy bar, or just a little nibble of a candy bar, or a cereal bar. Pardon me, I'm getting excited. Therefore, since we can eat just a portion, this domain would be continuous. It does make sense to eat half a candy bar, or a quarter of a candy bar, or an eighth of a candy bar if you wanted to measure it that way. So this would be represented starting from 0, continuous all the way to infinity. Let's say there is an unlimited number of, cereal bars. Candy bars just sound so much more fun. There's an unlimited supply of cereal bars at your disposal, so you could eat a quarter, you could eat a half, you could eat 1.5 cereal bars. Okay? So, a continuous set of data. This domain is represented from x is greater than or equal to 0. Because we could have fractions, because we could eat pieces, this is continuous data. We could have a value at any point in this interval. All the numbers would make sense in this situation. So these are the two types of data. The only way to tell again is by the context. This context, it does not make sense to buy half a bottle of apple juice at the store. The store will not let you. But in this instance, you could eat half of a cereal bar. So you're going to have to think about it in terms of the context of the question. Now let's take a look at how the graphs would differ for each of these scenarios. On the left side, we're going to make a t-table. There's only 4 values in our domain. We could buy 0 bottles of apple juice, 1, 2, or 3. So those are going to go on our input side of our t-table, our x values. Those are the only numbers that we can plug in for our domain. We're going to substitute each of those values into our original function for x, resulting in 1.25 times 0, which equals 0, 1.25 times 1, which equals 1.25, 1.25 times 2, which equals 2.5, and 1.25 times 3, which is 3.75. That gives us these ordered pairs. So x comma y gives us this ordered pair right over here. 1 comma 1.25, that's the ordered pair. 2 comma 2.5, that's the ordered pair. So those are the points that we're going to plot. On our continuous set of data, we're going to do the same thing. I just picked the same input values. For this situation, it would make sense if you wanted to plug in 0.5 or 1.5 or go all the way up to 5, 6, 7 cereal bars that you've consumed. I just picked a few points to plot. If we plug in 0 into this original equation, y equals 130x, we would do 130 times 0, which is 0. If we substitute 1 in for x, we would get 130 times 1, which is 130. If we substitute 2 in for x, we would get 130 times 2, which is 260, and 130 times 3, which is 390. These x and y combos result in these ordered pairs. So the t-table is set up to give you these ordered pairs that then we can plot on a graph. 0, 0, 1, 130, 2, 260, and 3, 390. So let's see what these would look like on an actual graph. And again, you might need to pause this video so that you can draw your own graphs and write your own table. Notice the scale is consistent. On my y-axis, 1, 2, 3, 4, each tick mark is worth 1. On my x-axis, 1, 2, 3, 4, each tick mark is worth 1 again. I've plotted our 4 points. 0, 0 is right here. 1 is an x value, so I went right 1 up 1.25 for that point right there. Over 2 up 2.5 is this point right here. And then over 3 up 3.75, and I did have to estimate those decimals right there. Now, would it make sense for me to connect those dots? In this instance, can I buy half a bottle of apple juice? No, I can't. So it would not make sense to have part of a line on top of this 0.5, since I can't realistically buy half a bottle of apple juice. So this graph is going to stay discrete points. It's just points on a line. It does not make sense to connect them. So we do not connect discrete data. We're going to leave it just as points. On the other hand, when we plot continuous data, these x values were not the only x values in the domain. I just needed to pick x values that were greater than or equal to 0, so I could have picked things other than these x values. I plotted these x values, 0, 0, 1, 130. Notice my scale is 100, 200, 300, 400. I'm counting by hundreds on the y-axis. On the x-axis, I decided to count by ones again. So 1, 2, 3, 4, 5. When I plot these points, I end up with 4 points on my graph. Looks very similar to our discrete domain example. But because this is continuous and our domain includes all of these pieces in between 0 and 1 and so on all the way to infinity, we are going to start at 0 with our first point, and it does make sense to connect these dots and actually go to infinity in the right-hand direction. We could eat multiple cereal bars all the way to infinity, assuming we had an unlimited supply. So we're going to actually draw an arrow at the end saying that this goes on forever. It does not make sense to draw an arrow at this end because we cannot eat negative cereal bars. Okay? So we have a dot here and then one single arrow going to the right forever. So discrete data is going to be a set of points, not connected. Continuous data is going to be connected, continuous the whole way through, and in this case going to infinity in one direction. So that's the difference between discrete and continuous. I hope you enjoyed this video. Please pause it, get all the notes down, and be ready for class. Okay, thanks.